Binomial radical expressions, we are going to work with the radicals. We're going to work with expressions, simplifying them. Like radicals are radicals where you have the same index and radicand. Like radicals are where both the index and the number, both the number, little number above and the number underneath are the same. So, for example, square root of 2 and the 3 square root of 2 are like radicals because the index, square root, and the number underneath, 2, are the same. Okay? Square root of 3 and the 4th root of 3 are not like radicals. Even though the number underneath is the same, the index is not the same. And the square root of 5 and the square root of 7 are also not like radicals. They have to look exactly the same to be like radicals. Okay? We're going to work on rationalizing the denominator. We actually did that before when we had i's. Remember, we had to remove the I from the denominator of fractions? That was rationalizing the denominator because we're not allowed to have square roots or any radicals in our denominator. We're going to work on that today with things other than I. Okay, yes?
So 2 and 3 are equal to the same, but 3 and...
Cube root 3 are not. No. They have to look exactly the same. The radical portion, the root has to be exactly the same. Both the index and the number underneath have to be exactly the same to be like radicals. Okay? Kind of like variables. X and x squared are not like variables. It has to be the letter and the power both. Okay, does that make sense? That's what the same idea. So, what we're going to be doing is combining with addition and subtraction radicals. And in order to add or subtract radicals, they have to be like radicals. If they're not like radicals, you cannot add or subtract them. And we add or subtract them just the same way we would do variables. For example, we look at the first one. I have root 5, root 5, root 5. They're all root 5s. That means they're all like radicals. If I can add 3x minus 2x plus 7x, if you can do that, you can do the same thing with the radicals. It's the same process. How many x's do I have? How many root 5s do I have? I have 3 root 5s. I take away 2 root 5s, and then I add 7 more root 5s. 3 minus 2 is 1. 1 plus 7 means that I have 8 root 5. When I'm adding and subtracting, they have to be like radicals, and just like with the variables, the radicals don't change. It's just how many of them I have. Okay, I have 3 bananas. You take away 2, then I add 7 more. How many bananas do I have? I have 8 bananas. Okay, well, instead of bananas, I got root 5s. Same concept. Okay, that's what that is. So I look at this one here, and I go, okay, I have 4th root of 2 and 4th root of 2. Those are like radicals. I have 6 of them here. I got 1 of them there, which means I have 7 4th root 2. And then I have minus 7 root 7. Well, root 7 is not a like radical, so it's minus 2 root 7. Just like if I add x's and y's and then it's combining up, I can't add or subtract x's and y's together. I got to keep them separated when I'm adding or subtracting. Yesterday we multiplied. Today we're doing the adding and subtracting part. Okay? You with me so far? Not too bad. And you look at the next one and you're going, yay, they're not like radicals, so I don't have to do anything. And I'm like, no, wrong. You have to try to simplify them if you can. I look at it, no, they're not like radicals, but we do know how to simplify radicals. Pull out the squares, that kind of stuff. So I have to look at this, root 12, root 75, root 3. Can I make them like radicals? Can I simplify them? Here's a hint on when you're doing this. I have one radical I cannot simplify at all. Root 3. Does 3 go into 12? Yeah. 4 times 3 is 12. So we've done this before. Square root of 12 is root 4 plus times root 3. So the square root of 12 is 2 root 3. Look, I've got a couple of like radicals. And then can I do the same thing with the square root of 75? Does 3 go into 75? Yeah, 25 times. So 75 is 25 times 3, so this is 5 root 3. So I have 2 root 3 plus 5 root 3 minus 1 root 3. 5 plus 2 is 7. 7 minus 1 means I have 6 root 3. Okay? So if they're not like radicals, maybe they can be simplified to be like radicals. No guarantees, maybe they can. I look at the next one, 4th root 5 and the square root of 5. Ooh, they're both 5, but one's a 4th root, one's a square root. I cannot simplify it. That's good as she stands. I can't do anything to that one. That's just the way it is. Okay. And so I get to this one, the cube roots. Okay. Cube root of 2. I cannot simplify the cube root of 2. The cube root of 54 and the cube root of 16. So the question is, can I simplify cube root of 54? And can I simplify the cube root of 16? Once again, just like I used the unsimplifiable one here as a hint, I do that here. Does 2 go into 54? Yeah, 2 times 27. And 27's a perfect cube. So cube root of 54 is the cube root of 27 times the cube root of 2. Because 2 times 27 is 54. And the cube root of 27 is 3. So this is 3 cube root 2. I was able to make them like radicals. And I tried the same thing with the next one. What about 16? 2 times what gives me 16? 8. 8. Ooh, 8's a perfect cube. So I go to here and I do the 16 one. Cube root of 16 is the cube root of 8. Cube root of 2. Cube root of 8 is 2, so that's minus 2 cube root 2. Now I can simplify. 5 cube root 2 plus 3 cube root 2 means that I have 8 cube root 2 minus 2 cube root 2. 8 minus 2 gives me 6 cube root 2. And the last one's really easy. Just because it's a variable doesn't mean the rules change. Square root of x, square root of x, square root of x, they're all like radicals. 2 plus 1 is 3. 3 minus 6. Negative 3 root x. Okay? Does that make sense? It's not too bad when you're adding and subtracting. They have to be like radicals. If they're like radicals, just add and subtract. If they're not like radicals, so you can make them like radicals by simplifying. Sometimes you can't. Okay, sometimes you can't. Your turn. Okay. So the first one, it's easy because they're already like radicals. Just add them together. 3 root 11 minus 8 root 11s plus 1 root 11s. How many root 11s do I have? 3 minus 8 is negative 5. Negative 5 plus 1. I have negative 4 root 11s. I owe somebody 4 root 11s. Okay. The next one. Ooh, they're not like radicals. Root 12, root 3, root 6. Well, square root of 3 I can't simplify. Square root of 6 I can't simplify. But we can simplify the square root of 12. We've done that often enough. You should know by now that root 12 is 2 root 3. We've done it so many times. You should, at some point, you should start remembering some of these. Okay? So root 12 is 2 root 3. I have 5 of them, so that's 10 root 3. And then I combine up the like ones I have. 10 root 3 minus 7 root 3 is 3 root 3. And then I still have plus 2 root 6. Okay? I can't combine those up. They're not like radicals. They're both square roots, but they're square roots of different numbers. That doesn't work. Get down to here, same situation. Cube root 2, cube root 2. Cube root of 16, we did this on the other page. The cube root of 16 is 2 cube root 2. So I can't make them all like radicals. They're all cube root 2s. 2 plus 9 is 11. 11 minus 5 means that I have 6 cube root 2s. Okay. And then I get to the next one. Uh-oh, I got cube roots and square roots. I might have to do a little extra work here. We know the cube root of 16 is 2 cube root 2. And I have 2 times that, so 2 times 2, that means that this becomes, 4 cube root 2. Can I simplify the square root of 18? Specifically, I have the square root of 2 here. 2 goes in 18, 9 times, 18 is 9 times 2. So I end up, this becomes 3 root 2. Now I combine them up. My cube roots, I have 4 cube root 2's here, another 4 cube root 2's there. That means I have 8 cube root 2's, negative 6 cube root 2, and this is a minus out here, minus 3 cube root, minus square root, negative 6 root 2 minus 3 root 2 means that I have negative 9 root 2. And because one's square root of 2 and one's cube root of 2, I cannot push them together any more than that. I'm done. Okay, it's like x and x cubed. I can't mix x and x cubed by addition. Okay. Questions? All right. Multiplying radical expressions. These multiply very similar to, and we did a little bit of this multiplying yesterday, but these multiply very similar to what you were dealing with x's and stuff like that. Same kind of rules apply a little bit. So like the first one, that's straight up. We did stuff like this yesterday, but then we had to simplify them. They do not need to be like radicals to multiply. They only have to be like radicals to add and subtract. Now when I'm multiplying, they all have to be the same root. So I cannot multiply a square root and a cube root, but I can multiply any 2 square roots together. So the first one, I multiply the numbers outside. 3 and negative 5 gives me negative 15. And then I multiply inside 2 times 7, root 14. Can I simplify the square root of 14? No, there's no squares divided into 14, so I'm done. I'm finished with that. But I do always have to think about that and check it. Okay. Next one, same idea. Negative 2 times 8, negative 16. Root 3 times root 2 is root 6. I'm done with that. I can't simplify that anymore either. And the last one, same idea. They're both cube roots, so I can multiply them. 5 times negative 6 is negative 30. Cube root 2 times cube root 5 is cube root 15. Those are easy. They don't scare anybody. The next ones do. But these are just like foiling. You foil. If you can do x plus 1 times x minus 3, you can do this. Okay, yes?
You said like root 5.
Oh, you're right. Thank you. Thank you. Thank you. Yes, I was wrong. Thank you for pointing out my errors. Make me look like a fool in front of everybody. And shame on the rest of you that were looking at me funny because I did something wrong but didn't say anything. She's the only one that had any guts to say anything. And yes, we're being recorded and I don't care. I'm hoping that someday somebody randomly decides to watch one of these things and they hear me go off on a rant like that just because I want to, just kind of, yeah, let's blow their mind and see what happens. That'd just be kind of funny. Wouldn't it? Okay. I do have one subscriber that's not a student. I do. I have one subscriber that's not a student. My son.
Wait, is he in college?
What? No, he's not. He just did it just because. Let's see if I can have Dad have more subscribers. I think I'm up to 13. Which for what I'm doing, that's actually not bad. Okay, so what we're doing here is we're foiling. You foil it out. Now you may have to do some combining of radicals and stuff after you foil, But when you're multiplying 2x plus 3, 2 plus root 3, 2 minus root 3, you FOIL. First, 2 times 2 is 4. Outside, 2 times negative root 3 is negative 2 root 3. Inside, root 3 times 2 plus 2 root 3. And then last, root 3 times minus root 3, which is minus root 9. All I've done so far is multiply. Now I want to simplify. Okay, simplifying requires a little bit of extra work, but it's not a lot. The square root of 9 is what? 3. So if I have a perfect square like this, okay, that's minus 3. Simplify any radicals I can simplify. Now combine up any like radicals, any like terms that I have. So I have 4 minus 3. What's 4 minus 3? 1. It's a coin slot. Negative 2 root 3 plus positive 2 root 3. How many root 3s do I have? None. So what's my answer? Okay? And sometimes things drop out. Sometimes they don't. They don't always count on things dropping out. This is a special case. What's the difference between these two things? Plus and minus. If they're exactly the same except for plus and minus, you'll come down to a single number. Okay, you will have a single number if the difference between them is plus and minus. You will have that happen. But only because it's exactly this with one is plus and one is minus, and that's the only difference. If we go to the next one, it may not work out so pretty. You still do the same thing. Your first step is to FOIL it out. 4 times 1 is 4. 4 times minus root 5 is minus 4 root 5. Negative root 2 times 1 is negative root 2. And then negative root 2 times negative root 5 gives me positive root 10. Are any of those radicals like radicals? Can any of those radicals be simplified?
Yes.
Which one?
Okay.
Well, okay, root 10, is there a perfect square that divides into 10? No, there's no perfect square, so I can't simplify it. So guess what? This is my answer. This is almost the complete opposite of what we just did. Almost the complete opposite of what we just did. The first one simplified down to one simple, easy number, and the other one, there was no anything we could combine at all. They're almost like the two complete extremes of what your possibilities are when you're doing this. Okay. 6 minus root 2 squared. I know many of you would be highly tempted to say, oh, that's 36 minus the square root plus the square root of 4. It's not. Because remember, 6 times 6 minus root 2 squared is not this squared minus that squared. You can't distribute squaring across parentheses. What this really is 6 minus root 2 times 6 minus root 2. Now, there is a shortcut for squaring binomial terms, but if you don't remember it, please rewrite it as 6 minus root 2 times 6 minus root 2 and FOIL it out. Because I don't want you to screw it up by assuming that, oh, I'm just going to square the first and square the second. You cannot distribute squaring across subtraction. Excuse me, across subtraction. So I get 6 squared, which is 30, or 6 times 6, 36. 6 times minus root 2. Negative root 2 times 6. And then negative root 2 times negative root 2, which is positive root 4. And then what is positive root 4? It's 2, so this becomes plus 2. And I combine up my like terms. 36 minus 2 is 34. Negative 6 root 2 minus another 6 root 2 gives me negative 12 root 2s. And the last one is very interesting. Yes, ma'am?
Why isn't the root 4 just equal to 2, not negative 2?
You're right, +2, my bad. Oh my God. People pointing out my errors, making me look stupid on air. It's okay. I'd rather have you catch mistakes and point them out. Isn't it supposed to be that? Yes, it is. And I usually screw up stupid stuff like that too. The big things, the big concepts I get right. It's the little things I always mess up. Okay. This one's going to be fun. Let me move the page up to give us a little room and move it up to the top. It's still foiling, and if you take it, one of the things is you look at this and you're going, oh my God, that's so big, that's so hard, there's so much going on. And you think, okay, wait, it's way too much to do. But if you do it part by part, it's break it down into piece by piece, it's easy to do. Okay? The Grand Canyon was not completed in a day. It took eons. Oh my God, I got to make a hole that big. I can't do that. Well, if you move a little grain at a time, and then a little grain at a time, a little grain at a time, yeah, eventually you'll get there, right? Same idea here. You can't do it all at once. And if you look at it and get overwhelmed, just say, wait a minute, I'm going to do it one part at a time. I know my first step is to multiply the first terms. Okay, 3 times -2, -6. Root 2 times root 2 is root 4. Okay. And I know my second step. Multiply the outside terms. 3 times -3 is -9. Root 2 times root 5 is root 10, not root 15. Multiply my inside terms. Root 5 times -2 root 2 is -2 root 10. And then multiply my last terms. Root 5 times -3 root 5 is -3 root 25. See, that part was easy, wasn't it? You just multiply these two things, multiply those two things, multiply those two things. That's not so hard. Okay. Now we start simplifying things down a little bit. Square root of 4 is what? 2. 2 times -6. That makes this -12. Square root of 25 is 5. 5 times -3 gives me -15. I can't simplify the square root of 10s, so now I just combine up any like terms that I have. My -12, -15, -27, -9 root 10 minus 2 root 10, -11 root 10. Like I said, you look at it and you're like, oh man, that's bad, it's ugly, it's nasty. Little bit at a time, one small step at a time, piece of cake. Okay. Your turn. Okay, so easy peasy. First one, -8 root 50. Can I simplify the square root of 50? 25 times 2. 50 is 25 times 2. So the square root of 50 is 5 root 2, so that's -40 root 2. Okay. Same thing on the next one. Multiply it out. 21 root 3 times 18. 54? Thank you. I'm trying to do it in my head. Is 54 simplifiable? Yes, 54 is 9 times 6. So this becomes 3 root 6. So 21 times 3 is 63 root 6. Is my final answer. I know, it's not fair. I made you do things that I didn't make you do on the first one on my examples. Get over it. Okay, FOIL it out. 2 times 5 is 10. 5 times root 3 plus 5 root 3. Root 7 times 2, -2 root 7. -root 7 times root 3 minus root 21. And that is not simplifiable. That is your answer. Okay. The next one is one where it's exactly the same, except for plus and minus. There is a shortcut to this. It's the square of the first term minus the square of the second term. So if you FOIL it out and combine up like terms, what you'll end up getting is take the first term and square it. So you take 2 and square it to get 4 minus, and then you take the square root of 5 and square it. When you square a square root, what do you get? You get the number underneath. So I get 5. I get 4 minus 5, which in this case is -1. Do not assume that the previous example gave an answer of 1, and this example gave you an answer of -1 that always ends up being 1 or -1. That's just dumb luck. Now, I could definitely pick other numbers that would make it completely different. Okay? This is 7 minus root 3 squared. 7 minus root 3 times 7 minus root 3 gives me 49 minus 7 root 3 minus 7 root 3 plus root 9. And once again, the square root of 9 is 3. So 49 plus 3 gives me 52. Minus 7 root 3 minus 7 root 3 minus 14 root 3. Okay. And then the last one, FOIL it out. A little more difficult, but not that much harder. 4 root 2 times -2 root 2 is -4 root 4. 4 root 2 times 3 root 3 is plus 12 root 6. Negative root 3 times negative root 2 is positive root 6. Negative root 3 times 3 root 3 is -3 root 9. And then once again, try to simplify my radicals. The square root of 4 is 2. 2 times 4, this becomes -8. The square root of 9 is 3, so I get 3 times 3, this becomes -9. Combine up like terms, -8, -9, -17. 12 root 6 plus 1 root 6 gives me 13 root 6. Any questions? Any screw-ups? Did I mess this one up too?
Not that it looks like it.
Okay, good. All right. Simplifying, rationalizing the denominator. We are not allowed to have square roots in our denominator. It's one of the rules that we have. Yes, I do believe it's an arbitrary rule, and at some point you stop worrying about this, but because this is something that's considered important, and you will see on tests, and people who are in charge of me tell me I have to do this, we're going to learn how to do this. It's actually not that hard. First one's the easy one. I'm not allowed to have square roots in my denominator. I will need to get rid of the square root of 7. Very easy. I multiply by 1. The square root of 7 over the square root of 7. What's that? It's 1. May not look like 1, but it's 1. I always multiply by 1. Why do I multiply by 1? Because it will not change the value. You have to understand, I'm changing how it looks. I'm not changing what it's worth. That's why I say I'm multiplying by 1. I'm multiplying by root 7 over root 7, which has a value of 1. So although I may change how this looks, I do not change what it's worth. Does that make sense? So that's kind of an important concept. That's why I talk about multiplying by 1. But I multiply top and bottom, numerator, denominator by root 7. Multiply it out. Root 2 times root 7, root 14. Root 7 times root 7 is 7. Can I reduce? Can I simplify my fraction? This is indeed a trick question. No, you may not, because 1 is inside the radical, 1 is not inside the radical. Right? The square root of 14 is inside the radical, 7 is not inside the radical. I can't reduce it because I can't divide 14 by 7 because 1's in, 1's out. I'm done. And that's it. That's to get rid of the radical. That radical is done. It's gone. No more square root by denominator. That's the easy one. The next one's a little harder. Remember when we did this, we had i's. We multiplied to get rid of the i's in our denominator. We did that. This works the same way. We multiply by the conjugate. Do you remember what the conjugate is? The conjugate is this with a minus instead of a plus. You just change the sign between the two numbers. So I multiply by 4 minus root 3. And I multiply numerator and denominator both by 4 minus root 3. Okay, I multiplied both the numerator and denominator by 4 minus root 3. Now my numerator is fairly simple. Distribute the 2. 2 times 4 is 8. 2 times negative root 3 is negative 2 root 3. Over. And there is a shortcut for multiplying by the conjugate. Square the first term. My first term is 4. I square that. When I square that, what do I get? 16. Minus. Square the second term. I take root 3 and square it. I get 3. No more radical. Now I do need to combine the two numbers, but that's what you do. So I get 8 minus 2 root 3. 16 minus 3 is 13. That's my answer. Okay? Let's take a look at the next one. Same idea. A little more difficult, but still the same idea. I still multiply by the conjugate. The conjugate is exactly what the denominator is with a plus instead of a minus. So I multiply by root 3 plus 5 and root 3 plus root 5. Root 3 plus root 5, root 3 plus root 5. Exactly the same except for plus instead of minus. Now my numerator on this one's easy. I just distribute. 2 root 7 times root 3 is 2 root 21. 2 root 7 times root 5 is 2 root 35. And then my denominator, same thing. I square the first term. I take the square root of 3 and I square it and I get 3. You square a square root, you just get the number in each. So I square the first term, I get 3. Minus, I square the second term, and I get, what do I get? I get 5. Square the square root of 5, I get 5. No more radicals in my denominator. That's what I wanted to do. Now I need to simplify. What's 3 minus 5? This becomes negative 2. Can I reduce my fraction? Is everything in there reducible by 2? Yeah, because I have 2 root 21 and 2 root 35. The 2's on my radicals are out front. And if I have a 2 in both of those terms, I can divide it by the 2 in the denominator. Everything has to be divisible by 2, and everything is divisible by 2. In fact, technically, I want to divide by negative 2, so I don't have a negative 1 in my denominator either. So if I divide both terms in the numerator by negative 2, I get negative root 21 minus root 35. And I can't do anything with that because neither one of those are simplifiable. Okay. This is where the ugliness happens. Because I have to FOIL my numerators, which means I have a lot more combining to do. But I still multiply by the conjugate. I still multiply by this with the sign changed in between. So I multiply by 4 minus root 3 and 4 minus root 3. And now I have to do my numerator like I was doing the ones before. I got to FOIL it out. 6 times 4 is 24. 6 times negative root 3, negative 6 root 3. Negative root 2 times 4, negative 4 root 2. Negative root 2 times negative 3. Root 3 is plus root 6. And then in my denominator, by the conjugate, so I got my shortcut, square the first number. 4 squared is 16. Minus square the second one. Square root of 3 squared is 3. And then I simplify whatever I can simplify. Can I combine up any like terms in my numerator? I got 24, I got root 3, I got root 2, I got root 6. Root 3, root 2, root 6 are not like radicals, so I can't add them together, and I cannot simplify them. So my numerator is unchangeable. My denominator, on the other hand, is 13. And you will end up with a single number in your denominator. You will end up with a single digit unless you have, like the previous one, where you can divide both whatever items are in the numerator by the denominator. You will not have any radicals left in the denominator. Okay? Uno más. What do I multiply by? 2 plus root 3. 2 plus root 3. 2 plus root 3. Foil out the numerator. And this one actually is going to simplify kind of nice, I think, when we're done. 1 times 2 root 3. 1 times both of those gives me 2 plus root 3. Oh, that's a lousy looking one. That's even more bad for me. 2 plus root 3. I do 1 times both of those. And then I do root 3 times 2. 2 root 3. And root 3 times root 3, which is, what is root 3 times root 3? 3. All over. And then I do my denominator. And once again, we have a shortcut. 2 squared is 4. Root 3 squared is 3. 4 minus 3. Oh, look at this one. This one is so sweet and easy. Because my denominator is what? 1, so I don't have to worry about it. Combine up like terms in the numerator. 5. And then root 3 plus 2 root 3 gives me 3 root 3s. See, it looked nasty, didn't it? But it came out all nice and pretty. Ish. Okay, questions? Okay, your turn. Do those. And then you get to take a quiz. That's enough of that. So, multiply by root 3 over root 3, and I get root 15 over 3. Multiply by 7 plus root 2 and over 7 plus root 2. And I end up with 21 plus 3 root 2 over 49. 49 minus 2, which is 47. Next one, I multiply by root 3 minus 2, root 3 minus 2, and it doesn't matter where the root is, which one I have. It's always exactly the same except for the sign between the two things. So 5 root 2 times root 3 is 5 root 6 minus 10 root 2. And then root 3 squared is 3. 2 squared is 4, so that's minus 4, which becomes negative 1. And I don't want a negative 1 all by itself in the denominator, so I just take the two items in the numerator and change the signs. Minus 5 root 6 plus 10 root 2. Questions on those first three? So, I had a question about this one. Once again, it's just the sign between them changes. So my conjugate is negative 3 minus root 2, negative 3 minus root 2. And my numerator will make more of a difference than it will in my denominator. So 2 times, so I have to FOIL it out. So I get negative 6, negative 2 root 2, negative 3 root 5, and then negative root 10. And then my denominator, negative 3 squared is positive 9. Root 2 squared is 2. So this becomes 7 in my denominator and nothing in my numerator can be changed. Okay? Same thing on the last one. Negative 4 plus root 2. Negative 4, negative 4. Negative 4 plus root 2. Foil it out. 1 times both of those. That makes that nice. Negative 4. Actually, I'm going to change colors for this part because it's a little close to the other one. Negative 1 times both of those terms gives me negative 4 plus root 2. And then I do negative 3 times negative 4, saying that negative root 3 times negative 4 becomes plus 4 root 3. Negative root 3 times 2 becomes negative root 6. And there is nothing I can simplify with that, because it just means a little less work when I'm done. Negative 4 squared is 16. And then minus square root of 2 squared is 2. So this becomes 14 in my denominator. And I cannot reduce anything because there is nothing that's in every item in the numerator that divides with the denominator. So fini. Did you get? Okay, you sure? You sure? Do you understand?
Yeah.
Okay. Because if you're not, don't be afraid. Go make sure you're right. You know what you're doing, I hope.